Okay, this video is an instructional video for the natural convection experiment. The natural convection experiment is basically meant to look at the heat transfer coefficient for a vertically heated plate. So the experimental setup consists of a reservoir of water, right? There's a reservoir with approximately 4 to 5 gallons of water in it. On the bottom of the reservoir, there's a hot water tank heater. The hot water heater is connected to a controller that controls the temperature of the water inside of the tank at approximately 93 degrees. It ranges between 92.5 to 93 degrees. On the front face of the tank is a plexiglass plate. The plexiglass plate is the vertically heated plate that you're going to be taking measurements on. Around the plate, there is a guard. This guard is meant to help protect the boundary layer development on the plate from ambient airflows, such as you moving in and out and causing air disturbances. This plate is supposed to protect the airflow on the plate from being affected by that. On the guard, there is a frame that holds a depth gauge. This depth gauge, on the tip of it, has a thermocouple that hangs over the tip of it that's meant to take the temperature of the air horizontally across at a distance away from the plate. And also, this frame allows you to pick different positions vertically along the plate in which you measure the temperature of the air horizontally from the plate. There are a total of 8 thermocouples used in this experiment to measure 8 different temperatures. The 8 thermocouples interface with 2 separate National Instrument DAC systems, 4 thermocouples to each DAC system. These 2 DACs are connected to a computer that's dedicated to this experiment. The thermocouples are numbered 1 through 8. 6 of the thermocouples measure the wall temperature of the plexiglass plate at 6 different vertical positions. And then there's 2 other thermocouples. One measures ambient air inside the captured space from the guard, and the other one is attached to this depth gauge that I just previously mentioned. The thermocouples are numbered as such, as TC. So TC 1 and 2 represent the first 2 vertical positions of the thermocouples measuring the wall temperature of the plate. TC number 3 measures air temperature inside this plate. Number 4 is attached to the depth gauge. 5, 6, 7, and 8 are the other 4 vertical positions measuring wall temperature of the plexiglass plate. In order to register the temperatures, there is a Labview executable that's been loaded onto this dedicated computer. In order to launch the executable, click on the icon on the left-hand side of the desktop called DAQ_TC8. Double-click on it. You should see pretty quickly a window that appears that looks like this. In order to start the application, you press on an icon that is basically a white arrow. You click on it, and the first thing it does is bring up a window for you to name the Excel spreadsheet to which the data is going to be saved. So I'm going to go ahead and just call this test. Press enter. Within a few seconds, you should see temperature measurements appearing in these fields on the right-hand side of the window. You can see that each temperature is associated with the thermocouple, TC1, 2, all the way up through TC8. TC1 and 2 measure wall temperature. TC3 is the ambient temperature. TC4 is the one attached to the depth gauge. In addition to the temperatures, you can see that there's a field here where you can call depth. That is going to be the depth at which you basically the position of the depth gauge relative to the vertical wall. I'm going to go ahead and take a minute right now and show you how that works. This depth gauge, again, has a thermocouple attached to the end of it. In order to set it up, first off, pick a vertical position. Your experiment handout will indicate which vertical position to start at, but let's say I start, let's go ahead and loosen the set screw on the left-hand side. You should see a Teflon set screw. Loosen that up. Move the vertical position to line up the depth gauge arm with the thermocouple. I'm going to go ahead and line it up with TC5 just for illustration. And then turn the set screw to lock it in place. There's two set screws on this arm. And go ahead and loosen both of them so that the arm moves freely. You're going to push the arm in until the thermocouple touches the vertical plate. Be careful. The thermocouple extends beyond a little bit further than the tip of the arm. If you push too hard, you can actually crush the thermocouple tip. The best way to go about doing this is to go ahead and look to the side, and as you push the thermocouple in, you should see it approach its reflection from the vertical plate. Push it in until it touches its reflection. Once you do that, tighten this set screw. This set screw attaches, locks the retractable arm to the base of the depth gauge. And then what you're going to do is take this this analog gauge here. You can turn it so that it lines up with 0. Okay, there's 2 zeros. Doesn't matter which one you pick. There's a 0 here, and there's another one 180 degrees away from it. Then what you're going to do is you'll see that there is a knob right here that you can turn in and out, and it causes this portion to move. What you're going to do is turn this knob until you lock this movable part of the depth gauge to the base, and then lock this set screw in place. And then go ahead and release the other set screw. What that does now is that as you turn this set screw, it actually pulls the thermocouple. The arm moves away from the plate. And you can see the needle move as well. As the needle moves, it indicates the distance in which you're moving away from the vertical plate. Each little sash mark on this in this dial is 0.001 inches. So what you want to do is that you want to measure the temperature that the thermocouple on this depth gauge measures, starting from the thermocouple touching a wall, and then measure the temperature that it measures at 0.001 increments away from the wall. So what you're going to do is first, with the thermocouple at the wall, you're going to go to the computer and you're going to go ahead and enter in 0 for the initial measurement. That's for a depth of 0. Thermocouple touching a wall, distance of 0. Make sure you have the correct position number selected. Positions 1 through 8, actually it should be positions 1 through 6. Select the appropriate position number, and then press Acquire Data. Then go up to the depth gauge, turn the knob until you pull the thermocouple 0.001 inches away from the wall. Go back to the executable. Change the number in the depth field from 0.000 to 0.001. Press Acquire Data. Then go back to the depth gauge, do 0.002 inches, 3, all the way up until 0.01 inches. 0.01 inches will be when the needle hits the 90. You should see a number 90. That corresponds to 0.01 inches. Once you get to temperature at that point, increment the distance of 0.01 inches. So from 90 to 80, that would be 0.02 inches, 3, so forth and so on, until you get all the way to the other 0. The other 0 indicates a distance of 0.1 inches. At that point, detach detach the arm from the base by loosening the set screw. Now you can actually move the depth gauge by hand. So pull it out to 0.2 inches, take the temperature, 0.3, 0.4, and so on. You already keep doing that and measuring temperatures until you see TC4. Again, TC4 is the temperature measured on the depth gauge, until that equals TC3. TC3 is the temperature, the ambient temperature. They're not going to be exactly equal. They're going to be anywhere from 0.5 degree to 1.5 degrees off. But once you see that, go ahead and take another 3 measurements. In other words, increment another 3 times to make sure you're outside the thermal boundary layer. You're outside the thermal boundary layer when the ambient temperature should equal the temperature measured by the movable thermocouple. Every time you press acquire, so back to this executable, every time you press and acquire and write data point, it writes a data point to the Excel spreadsheet that you just created. So the Excel spreadsheet you created should be on the desktop on the left hand side. So the one that I created was called test. You can actually click on it. It'll bring up the file. You can just click yes when this window comes up. And you can see all the data you recorded, the position number, the depth, and then TC 1 through 8. Just try to be careful. You cannot write to the Excel spreadsheet when it's open. You will crash the executable. Make sure that it's closed. And again, make sure that you have the correct depth and the correct position number when you record your data. That's about it, and that concludes the instructional video for the natural convection experiment.